Hello everyone and welcome to our Blazor SignalR tutorial. My name is Rüdiger Drees. I've been working as a software architect for over 25 years. In this tutorial I would like to demonstrate how to implement a small client application to display stock quotes, which are constantly updating and changing, feeding through a backend service. Demonstrate the results of our sample. You see the grid is constantly updating the price information that it's receiving from a backend service. Quickly go to the agenda of this tutorial. We are going to create a Blazor ASP.NET Core hosted progressive web application. Implement the server components, the SignalR-Hub, the background service, and build a small Stockquote server mock. We're going to configure and set up the server side and then implement the client. Build a client component to display these stock quotes we just saw in the sample. Configure it, test run. And then I'm going to discuss an issue on the rendering performance and take a quick summary. Okay, let's jump right into Visual Studio. Start by adding a new project. Select the Blazor app template. Call it Blazor SignalR. We will select the Blazor WebAssembly app. HTTPS is not required for this sample, and select ASP.NET Core hosted and the PWA option to be able to install it on it. Okay. Next we define the Stockquote object, which is the object representing one row in our grid here. That is the Stockquote object. Place it in the shared library so it's accessible from the server and the client side. To speed things up a little bit, just copy and paste the properties I've already defined, like symbol for the stock quote, the price, percent of price change, recent price, volume, and the time of the price change. Additionally, we add a method to update all the properties once we receive a price change object from our quote server. Okay, to start implementing the server side, create a new folder called services. The first definition is a interface for the quote pump. The quote pump will be the mock delivering the stock price changes. Call it quote pump. Once a price change occurs, it will fire an event and send a new stock quote object with that event. Quote update, add the missing using statement. After that, we add a method to actually start the pump. This requires a cancellation token. When the service is shut down, it'll send a signal requesting the cancellation using this token. Add the threading namespace using statement and implement it. Quote pump derives from our interface definition. And implement the event and the frame for the start method. In this quote pump, we will have a list of our stock quotes that we want to simulate the price changes for. That is done to this list of stock quotes. When we create this object, this quote pump object, we will initialize the list we just added. That'll only happen once, of course. And we will add the sample stocks we want to display price changes for. Just add some samples. The implementation of the actual pump is done in here. Basically, this quote pump wouldn't, in the real world application, wouldn't be placed in the same library as the server. It would be an external component, external definition placed in a separate library. I'll just quickly go through what we're doing here. So while the cancellation request is false, we define our 3 randomizers and create sample price changes. That's done in here. Calculate from the recent price, just add some random values to it. And the time of the price change, the volume is also calculated randomly. And then we fire the event and send this new quote with it. Then define a small delay. And that's it. That'll simulate constant price changes. Okay, let's build it, see if everything works until now. Good. Next step is to define an interface for our quote hub, which will be the central point of where the clients connect to and receive the price changes from. In this interface, we will define 2 methods. First one is as a task, send quote info. Quote info. And also send a Stockquote object with it. Additionally, we add a general method just to send a string or a message to all the connected clients. We will use that to send the messages shown in here, where we inform all the clients if a new client has connected or disconnected. That's where we're going to use this method for. Okay. interface is defined, then the next step is to add the implementation for it. Stockquote Hub. Here we actually derive from the hub definition, which is placed or comes from the SignalR implementation. And that looks like this. We add our interface in there as a type specifier. Okay. In here we will override the connected and disconnecting methods. As shown in the interface definition in here, we will inform all the connected clients when a new client is connected. And that is done in here. Okay, and just add the code already defined. Define async awareness to store the connection information when a new client connects to our hub. We use this static definition, the user handler. Just add it here for now. Okay. Here we send a message when a new user connects. Same when a user disconnects or client disconnects. Then we send a message to inform all the clients about the disconnection and remove it from the list. Additionally, we must implement our two methods that were defined in this interface. That is done. These methods are very simple, that's why I'm just going to paste them in here and explain it. Okay, this is the send quote method, the using statement, and the quote hub message. Just send it to all the connections. Okay, build our solution. Now we've got the quote pump that delivers the price changes, the hub that sends those changes to all the connected clients. Next, we will add the service that actually controls all that on the server side. It's going to be called quote worker. Derives from background service. And gets called via execute async. We need the constructor for the quote worker, which will receive the instances of our services we just defined and implemented. The quote pump, the quote hub, add some missing using statements. We will define. Via dependency injection, the quote worker receives the logger, hub, and pump. Okay. Find some read-only fields to store the instances that we get delivered. This must be defined async as well. Okay. When this service gets started with the execute method, then we will hook to this event, quote pump. Here we will receive the price updates. Add this method, that's fine. Additionally, we must remove the event handler, and in between that we run it. Requires the stopping token, stop token, and is run asynchronously. Okay, that's quite straightforward. So when a price change occurs, so very simple one call to the hub method. Async void is fine here because it's an event handler, and we call this quote, and that should be fine as well. Okay, that's it for the background service. Quickly build it, see if everything's still fine. After that, we will up the services in here, configure them. Just add that predefined code in here as well to speed it up. We will use SignalR and add a service for the compression of the responses. Straightforward. Okay. Additionally, we must add our background service in here as well. We will do that here. Quote worker. Add the using statement for it. It will probably fail now. Let's just run it and see what happens. Okay. It throws this error or this exception mentioning that it is missing something. Resolve the service type quote pump. It's expected because we haven't added the instance of it to the backend service list. So we create a singleton of I quote pump initiated with this call right here. Okay. Now it should start without that exception. A bit slow, but okay, no error. That's fine. Okay, it's not finished yet completely. We must add the endpoint for the hub. That is done right here. Endpoints hub quote hub. Okay, down to hubs quotes. That defines the endpoint for the SignalR-Hub. That should be it for the server side. We can start implementing the client side. Add a folder for our client components. And add the Blazor component to display row in the grid. One Stockquote. I'll call it Stockquote display. That will be done to one table row. Okay, now we must pass one Stockquote item to this component. And define get setter. Unknown must add Blazor SignalR shared Stockquote. That looks better. Okay. The positive price changes will be displayed in color green, and the price drops will be displayed in red. So this is done through style definition, and here we're with our quote object price rise. If it's rise is meant as a positive change boolean, then it will be green. A drop will be red. The percent of the price change formatted with 1 decimal, and also displayed in the color green or red. We display the volume and the time of the price change. That's it for this component. But now this must be a public parameter, because that was missing. Okay. IntelliSenses, there we are. Initialized async. I just had this already here. We will add some code in here later when we discuss the price changes. Okay, now that we've got our client component defined, we can start to use it. I am going to modify this existing fetch data page, which can be used for our stock quotes. Just to remove the parts we don't need right now. Instead of the weather forecast array, we're going to use a list of stock quotes items. Call it quotes. Remove this call. Remove this part and the body. Quotes. There we are. Okay. Next part is the definition of the hub connection. To do that, we must add a NuGet package to our client. And that is the ASP.NET Core SignalR client. Should be found. This is version 5.0, not preview anymore. Just been updated. Okay, quickly add that. We will need another NuGet package. Called the system text encoding web. That is also in version 5.0 now. We add this to the client as well. That's fine. Then we can add the using statement for that. It's the Microsoft Core SignalR client. Okay, hub connection is known now. We're going to add our Blazor component. That is done to using statement client components, and to display the stock quotes we define a for each loop. We loop through all the quotes and add a stock quote display for each of the quote items and set the parameter to each item in the list. Okay. Just quickly add the definition for the header of our table. Okay. Next part is, or the next step is to actually connect to the hub. To resolve the URL, we need an instance of the navigation service, navigation manager, sorry. Add this with a statement in here. And on our method, on the initialization method, we can call the initialization of the hub connection, new hub connection builder with URL, and there we need our navigation manager instance and to absolute URI, just add that in a minute, and we call build. Great. Okay, I think it was called hub quotes. Just check on the server component. There we go. It's fine. Okay. Next step is to define the method on the hub. Method calls, and the first one is the general messages from the quote hub. The method for that is called quote hub messages. Exactly. Message receives for that we just need a small snippet to actually display it. Put a small little info, call it info text private. Add our property on that, our field. And when a message is received, we just set this property and update play. Okay, there's a one error displayed in here. Build it and check it. Should be fine. Okay, now we will implement the handler for incoming stock price changes from our hub. Therefore, we add a handler for Stockquote update. The message is called set Stockquote info. Call it Q. We will check our list to find the index of the stock quote that the price change has occurred for. We compare the symbol Q in quote.symbol. If the item doesn't exist in the list, we will just add it to the list. we add the quote item, refresh the display. Otherwise, we will modify this later, but for now we're just going to set the new values due to a call to update quote data. And for now, add state has changed as well. Okay, one thing is missing now. We must start our hub. That is done to a call to the start async method. Okay. There is a warning. Okay. We must initialize our list. And I think this is called hubs. Another go. No more warnings. Press R. The cache must be refreshed with Control F5, and then we can see the first run of our sample. Great. Okay, we're missing the information message display here. Now we're going to check that issue. That is correct. Quote hub messages. Maybe there's a typo in there. Quote hub. Quote hub message. That could be the problem. Run it again. Doesn't show up on the first time, then refresh the cache again, and there we can already see the expected result. Now we receive an information when a client has connected. Quickly open another instance of our application. Their client count is 2. That's what I was just checking. And now if I leave the page and return, we can see that we are receiving the information that there are 3 clients connected. This is basically wrong. We must change that. The problem is that the hub connections aren't closed automatically. What we must do for that, we must implement the disposable interface and call the stop method for the hub connection. Do that like this. Just get that snippet from here. One line of code. Exactly. If it's not null, call the stop asynchronous method. Okay, verify that that works correctly now. Unfortunately, it's slow, very slow today. Starting the app. Okay, so just open another instance. Same issue as before. Refresh the cache. And for this one as well. As we can see in the background, that one's quickly reduced to 1 and then increased again. But what I want to see now, we've got 1 in here. Our 1, and now two connection. 2 clients connected, and there is the second one. If we leave this page, it reduces to 1. Okay. Close this one as well. Okay, now that our sample is working, let's have a look at optimization that can be done in the rendering part. On this line, we're refreshing the state each time we receive a quote update. That isn't optimal, because it should basically just refresh one row in the grid and not the complete page. To demonstrate that, first of all, add a few more items to our quote pump in here. So that list, and if I run the application again, then we should see that we are not receiving any more changes on the price tags after all the items have been added to the list. We're receiving price changes, but the list is still growing because we're adding the quote items here and refreshing the page on the next line. Now the list is filled. It's basically dead. Prices aren't displaying, the changes aren't being displayed anymore. Okay, to get that to work in a more efficient way, we will use the event technique in here as well. Therefore, on the quote update, I will fire an event. Just copy that. Let's just write it. It's not a big thing. Event handler dated. There we are. Okay. What we must do then is hook to this event on the. It's already compiled it. And in here we don't need the first parameter. I think there's only one anyway. If we receive a change, it has changed. Okay. That should be it already. Remove the refresh here, the refresh command, and added it locally to the component. Let's verify it. Okay, I think I must press Ctrl 5 anyway to refresh the cache, but it's looking much better already. Prices are still changing. Okay, let's check the task manager for that. Not the most accurate performance measuring tool, but it'll do for our little sample. We can see that we're around 1 to 2%, basically below 1%. And okay, let's take that back again. We'd take this out and add this version again. Probably must refresh the cache again. Control F5. And in here we can already see that we've got a significant rise in the CPU usage of the Edge browser. We'll close that. Put it back again. Open our task manager. This will hopefully start quicker now. Okay, refresh the cache once more. Go over here. And we can see that the CPU usage is constantly dropping to a much lower rate than before. Okay. Let's refresh it again, be sure. Okay. Good. Fine. There we can see how just 2 or 3 lines of code can dramatically increase the performance and reduce the usage of resources on the machine. Yeah, that's it for this tutorial. Quickly summarize. We implemented a hub, a quote pump, and a background service on the server side of our Blazor application. Added the Razor component to update price information. The next steps would be to have a look at the gRPC protocol to optimize the data, the amounts of data, the compression, etc. Because we are using a JSON format right now by default, and that can definitely also be optimized. The other part would also affect the rendering on the client. Lately, with the Blazor updates, it's been a virtualization component introduced, and that must be checked out if it'll gain another step on the performance part. Oh, I hope you enjoyed this video, and bye for now, and see you on the next video.